Thermochemistry Extra Practice Example number 4. In this problem, we are looking for delta H for this reaction given this following multi-step or this multi-step piece here. So we're going to figure out what we need to do to manipulate these to cancel and eliminate anything that we don't need and only end up with this. The way we did that, if you recall, is we'd letter them A, B, and C, and so on. And then we're going to figure out what we have to do to each one. So let's start with A. So what are we doing here? We are going to look at our unknown. This is our unknown for we don't have delta H for. And we're going to look at A, which is this top one right here. And we're going to evaluate what in our unknown is also in our known. So I see C2H6 gas, C2H6 gas is in our A, and it's also in our unknown. If you recall, when we practiced this in class, I encouraged you not to use H2O2 or H2O as your focus point unless you had no other options. So I don't want to focus on O2 here or H2O. I would be focusing either on C2H6 or CO2. So I focused on C2H6 gas in A because I also have it in my unknown. In order to get it in the proper position, I would have to reverse this reaction because I need this on the other side. And I have one and need one, so I need to multiply by 1. So here I'm showing that I reverse it to get it on the other side and multiply by 1. I physically am going to reverse it, so these became reactants, these became products. When I reverse something, I change the sign, so that's why the negative, this should be negative here. Oh, nope, I'm sorry. We did change it positive. We changed it positive from the negative. I thought I was showing more details here, but I'm just showing that I changed it to positive. If I multiply by 1, I get that. Now, let's look at in B. So in B, what do we see in B that we also see in our unknown? In B, I see C2H4. C2H4 gas, I have it in both my unknown and in my known and my unknown. I have it in my unknown and I have it in my known for B, so that's my focus point. What do I need to do to get it in the proper position? I need to keep it forward, and I need to get from a half to 1. So think about this. We're always thinking about what we multiply by. And all of these, Hess's law, this is what this is Hess's law. We always think about for to reverse, what do I multiply by? So we are going to multiply by, to get down from a half down to 1, we're going to multiply by 2. So I multiply through by 2. So I multiply through by 2 and I keep it forward. This becomes 1, this becomes 3, this becomes 2, and this becomes 2. I kept it forward, so I keep it as negative 705.5. I multiplied by 2. When I did that, I got a negative 1411. And now we're going to evaluate the final one. So in this final one, I'm going to see if there's anything in here that I can focus on that's unique to this, meaning that I have H2 gas here and H2 here, but I don't have H2 anywhere else. Okay, so I focus on something that's in here, in this case H2. I know I need H2 to be a reactant, and it's H2 is a reactant, and I need only one of them. So I'm going to keep it forward because H2 is on the proper side. It's on the reactant side here and here, so I'm keeping it forward, but I need to get down to 1, so multiply 2 by a half. So this becomes a 1, this becomes a half, and this becomes a 1. When I do that, I'm going to also multiply through this through by a half, and I'm going to keep the sign negative. So that's what I did there. The final piece, before you do anything with these numbers, is you want to make sure that things either reduce, sum, or eliminate to end up with only these pieces. So let's go through that next. Let me get my pen ready here to do that. We're going to go through that piece. I think we'll use the yellow. Oh, let's use the black to do that. Okay, so as I look here, I see that I have liquid water, 1 liquid water, 2 plus 1. So these 3 liquid waters are products. We'll eliminate the 3 liquid waters as reactants. I also see I have 2 CO2s here as gas as reactants and 2 CO2 gas as products, so they will eliminate. And then I'm looking to see what I need to do with my oxygens. Well, I need my oxygens to disappear. I have 3.5 on this side and 3.5 on this side, so they disappear, leaving me left with what I need. As a reactant, I have C2H4 gas and H2 gas going to C2H6 gas. So I know I've done that part right. The next piece is to make sure that Let's see, I reversed this, so I should change the sign from negative to positive. I multiply by 1, I get that. Kept this forward, so the negative 705 stays there, but I multiplied by 2, so I'm multiplying by 2. Kept this forward, so I keep the negative sign down here, yep, and I multiply by half, multiply by half. These are my new values, and then I'm going to sum them, and my final answer is negative 136.8 kilojoules.